Welcome everyone, and thanks for joining us today. Today we're going to be hearing from Professor Peter Ryan about bottles, lids, and the lockdown and the marine litter monitoring.
All right, everyone. So I have given a version of this talk before, so hopefully you didn't sit through it for the second time now. For those of you who don't know me, I'm primarily a bird watcher. I've also been around for quite a long time, so I started studying the impacts of plastic ingestion on seabirds back in the 1980s for my master's project. And already by that stage, certain species had very high levels of interaction with plastic. So for example, these great shearwaters, which is a common breeding bird at the Tristan da Cunha Islands, 90% of them contained ingested plastic in the mid-1980s. And as a result of my sort of ongoing research, we've been tracking how this population has responded to that over time. And this is the most polluted great shearwater that I've ever seen. This was a bird that we found dead at the breeding colony on Inaccessible Island in 2018. What you'll see is that there's been a shift in the type of plastic that's been eaten over time, from industrial pellets, or nurdles as they're often called, to more fragments of user items. But generally speaking, the amounts of plastic in this bird has not changed dramatically, nor in most of the other species that occur over the last three decades or so, which is kind of interesting. So back in the 1980s, I published a whole bunch of papers looking at the impacts of plastic in seabirds. And because I've been working in this field for a long time, I was asked to write the history chapter in this really nice open access book. If you haven't got a copy, I'd encourage you to download it from Springer on marine anthropogenic litter. Which makes me feel kind of old that I get asked to write history chapters. But I think it's perhaps worth making the point that because I have been in the field for more than 30 years, it does give me a slightly different perspective. So I went to the second and third International Marine Debris conferences in the 1980s and the 1990s. And already by the third conference in Miami in '94, the clear consensus was that we knew there was a problem, and the focus should be on solutions rather than more documenting the problem. And I think that's something that people have kind of lost sight on. You know, we've known that this is a significant problem for 25 years, and yet we still seem to spend an awful lot of time just telling people it's a problem. Given that we need to be solution-oriented, we need to obviously tackle the causes of the problem, nothing new there. And one of the first questions, if you are going to tackle the problem, is where does all the marine litter come from? And when I started work on the problem, it was clear that a large proportion was being dumped from boats and ships. So it was only at the end of the 1980s that MARPOL Annex V came into force, which banned the dumping of plastics and other persistent wastes into the ocean. And since then, it's been kind of widely assumed that about 80% of plastic litter in the ocean comes from land-based sources, but the basis of that assumption is perhaps not terribly well documented or necessarily challenged. And it depends very much where in the world you are. So here's a South African-centered view of the world, but if you go out into the middle of the ocean, you might get a different perspective. And so one of the places that I've been working since the 1980s is an island in the Tristan group called Inaccessible Island. And there, this is what the beaches look like. It's an uninhabited island, so nobody ever goes there to clean up. And there's just an awful lot of fishing-related debris. And more than 90% of the plastic on the beaches here comes from fisheries and shipping-related activity. And that's just the obvious stuff. But what we've seen over the last 30 years is a particularly dramatic increase in plastic bottles. And so we wanted to ask the question, what about general waste? We can see that floats and big ropes and things are coming off ships, but what about the general waste that we find? This could be drifting from land-based sources, or it could be coming off ships. And indeed, the fastest growth rate of litter on this island has been in drink bottles. So we've seen about a 15% per year increase in the amount of drink bottles on this island. You see the data points are rather sparse, but it's a fairly good fit. And this is despite the fact that bottles turn over much more quickly than other litter types. This is because they're relatively lightweight and they get blown into the backshore vegetation where we don't find them, or they get blown back out into the sea compared to things like floats and ropes and so on. And so if we look at the proportion of bottles in newly arrived litter, almost 3/4 of all the litter washing up on this island are plastic bottles. So it's really interesting to see where these are all coming from. And the nice thing about bottles is that they give you lots of information. If you're lucky, they still have a label on them, which might have a barcode or usually a manufacturer's address, so you can see which country they've been made in. But even if you've lost the label, you can still often work out where a bottle comes from the marks on the lid or on the neck. And using this approach, we've been tracking where the litter came from over 3 decades. So in the late 1980s, more than half of the litter on this island came from South America. By 2009, Asia had increased to the point where it was about equal with South America. And by 2018, almost 3/4 of the bottles arriving on this island came from Asia, which is pretty much counterintuitive. Most of them came from China. If you look at this nice little website, plasticadrift.org, which allows you to put a little rubber duck anywhere on the world and see where the plastic going from there would disperse. It's something that Eric van Sibyl put together some years ago, and it tracks the distribution of plastic particles for 10 years. So this says if we look at litter coming out of, let's say, Montevideo or Buenos Aires, it would typically end up circulating in the South Atlantic Gyre and wash up on Inaccessible. If you look at litter released from mainland China, you would see that it should end up in the North Pacific Gyre and not get anywhere near Inaccessible Island, certainly within 4 years. And the other nice thing about bottles is that they often have date information, either production dates, expiry dates, or both. And you can see sometimes on more solid items, they have this kind of wheel thing, like in the bottom right there. So that's the oldest item we've actually found on a beach so far. It was made in March 1971, so substantially older than most of the audience, I would expect. And if we look at the ages of bottles on Inaccessible Island, we find that there's some that go back, as I say, more than 30, 40 years, but the majority are relatively young, less than 4 years old. That's the standing stock. If we look at the newly arrived bottles, most of them are 1 to 2 years old. So again, this is not consistent with bottles drifting from continental areas, particularly from Asia. So on the basis of that, we concluded that most of the general litter that we were finding was being dumped illegally from ships. And that's just mapping the origin of the bottles from around the world at this very remote island in relation to shipping routes. So here's Inaccessible sitting on a sort of a composite map of shipping intensity around the world. And you can see it does lie on not a very busy, but a fairly busy shipping route. So you might say, well, that's typical of a very sort of busy shipping area. What happens if we go to a part of the world where there's much less shipping activity? So in 2019, just before the shit hit the fan with COVID, I was fortunate enough to be able to go and do some field work in Pitcairn. And then we also wanted to look at continental areas. So we've also looked at using this approach in South Africa, which is obviously on a very busy shipping route, and Kenya, which has some shipping, but much less than South Africa. So let's first go to Pitcairn. This is the Pitcairn-centered view of the world. It's all ocean. And because it's not on the way to anywhere, there's not a lot of shipping in this part of the world. And yet it's quite notorious for having one of the dirtiest beaches in the world, thanks to this paper in PNAS in 2017 by Jen Lavers and Alex Bond. And this is the East Beach on Henderson Island. Again, you can see most of the junk there is fisheries related, lots of buoys and ropes and shipping type litter, not necessarily coming from land-based sources. In fact, that East Beach is rather atypical. If you go to other islands in the Pitcairn group, they tend to look like this, actually quite idyllic and relatively pristine in terms of litter. But if we look at where does the litter come from in the Pitcairn group, we find that once again, it's dominated by Asia, mainly China, followed by South America, Oceania, etc. If we contrast that with Inaccessible, the pattern is pretty similar. And if we look at the brands, we find that the top polluters on Pitcairn are very similar to the top polluters at Inaccessible. And indeed, if we look at the ages of bottles, although we don't have newly arrived dates, the ages of the standing stock of bottles is very similar to that seen on Inaccessible. So it seems that even here in the middle of nowhere, shipping is responsible for a large proportion of the drink bottles washing ashore. What about continental areas? I first did this work in Kenya, where there's a huge market for bottled water. This is actually on a beach in Kenya, in Mombasa, and people have sort of piled up all of the plastic bottles into an ad hoc dump at the back of the beach. And sampling 10 or so beaches along the Kenyan coast, found 89 different bottled water brands. It's just hugely diverse, but fortunately, there's only a limited number of manufacturers of the actual bottle blanks, and so it's fairly easy to tell which bottles come from Kenyan versus other manufacturers. And of course, if you're dealing with a continental area, you have to try to distinguish local litter from offshore litter, whereas on an oceanic island, it's pretty much all coming from offshore because there's nobody living there. And to control for imported materials, we just kind of monitor a sample of street litter. So if you go onto a street in Mombasa or Malindi or any of the other coastal towns in Kenya, 99% of the rubbish there comes from local Kenyan sources. And the pattern is very similar. If you go onto the beach at Malindi and Mombasa, there's about 4 or 5% foreign litter. But as you move away from those urban centers, you start to see a higher proportion of foreign-based bottles coming in. And as you go to really remote beaches, the foreign bottles come to dominate, which has really interesting messages about dispersal. We think that bottles travel very large distances at sea, but this certainly doesn't indicate that, because if the bottles from the urban source areas were dispersing very large distances, we wouldn't see these steep gradients in terms of the proportions of local versus foreign litter. Where are they coming from? 2/3 from Kenya, 9% from the rest of Africa, from a diversity of countries. But once again, Asia is the major culprit. If we move to Cape Town or South Africa, this is a particularly bad picture of Cape Town. Our beaches don't normally look quite so bad. This is after a rain event at the mouth of the Rich River in Milnerton. Same approach used. Let's look at street litter. Virtually all of street litter in South Africa is South African made products. We go down to the beach at Milnerton or Greenpoint. Again, the same sort of situation, a small proportion of foreign, but virtually all South African. But as we move away from the urban center, we see the foreign component getting larger and larger until, if we go to really remote beaches, we find once again that foreign litter is dominating. And this is just around Cape Town, but we've done this all up the East Coast as well. And we find the same pattern occurring around the major urban centers of Port Elizabeth and East London. Where does it all come from? Once again, predominantly Asia, and most of the Asian bottles coming from China and Singapore, Malaysia, and associated with shipping. So the message from this part of the talk is that we need better enforcement of MARPOL Annex V, because despite the fact that dumping of plastics and from ships is illegal, those regulations are not necessarily being enforced. And the best way to do that is through better monitoring of the use of port reception facilities. So when ships come into ports, they are supposed to offload all of their persistent wastes into port reception facilities, but there doesn't seem to be sufficient monitoring of this process. So vessels should be obliged to either offload their waste or demonstrate how they've dealt with their waste when they come into port. However, it's all not quite as straightforward as you might think. There are differences between different types of bottles. So most of the data that we get comes from PET drink bottles, but we also get data from HDPE bottles. And HDPE bottles behave rather differently at sea. Unlike PET bottles that sink when they get full of water, HDPE bottles continue to float because they are made of a polymer less dense than seawater. And so they have the potential to drift perhaps much longer distances. And we often see evidence that they've been at sea for some time, like these very distinctive bite marks, presumably from sharks, on bottles, which are quite common, particularly in tropical waters. And so if we look at the origins of litter on the south coast and the southeast coast versus the west coast of South Africa, we find more South American litter on the west coast, which is kind of what you'd expect if there was some long distance transport. China, we actually find more on the west coast than the east coast, which doesn't really make geographic sense, but obviously most of the Chinese bottles are coming off ships. India, we see a slight dominance on the east coast, which suggests maybe there is some long distance drift from India. But when we get to Indonesia, we find this huge discrepancy. Many more Indonesian bottles on the east coast than on the west coast of South Africa. And that suggests that there's something fundamentally different about bottles from Indonesia. And this is reinforced if we look at lids, loose lids. So if we look at PET bottles, we get 78 Chinese PET drink bottles for every 1 Indonesian drink bottle. But when we look at the lids from those bottles that are loose, washing up individually, we find 33 Indonesian lids for every Chinese lid. So there's a massive swing between intact bottles and loose lids. So PET bottles are really only telling you part of the story. And what seems to be happening is for the HDPE products, either bottles or loose lids, is that they're actually drifting all the way across from Southeast Asia. And the predominant current from Southeast Asia across to Africa is the South Equatorial Current, which divides when it hits the East African coast around Kenya and feeds into the Agulhas Current, which sweeps all the way down the coast of South Africa. The origin of that South Equatorial Current is basically Sumatra through the Indonesian through flow. So all of the rubbish that's coming out of Indonesia, which is the 2nd largest polluter, or maybe the 3rd largest polluter of plastic into the ocean, depending on who you believe, but certainly a major source of plastics into the ocean, is feeding into this South Equatorial Current and being carried across the Indian Ocean to hit the African continent. And if we can see the effect of this longer time at sea, these are sort of lids from bottles that have been dumped from ships, a whole bunch of foreign bottles, but their lids all look fairly intact and nice. And this is what loose Indonesian lids look like. These happen to be all Danone Aqua, which is the most common brand, but we've picked up about 10 different brands of Indonesian bottles on South African beaches. And they all tend to look like this. They look like they've been chewed by fish, and they're often colonized by bryozoa and other epibionts. Okay, so I think the message from that first whole section of the talk is that there's still a lot of dumping from ships, and there's also some long distance drift, particularly of inherently buoyant plastics. But having said that, let's come back to our 80% from land-based sources and look at the evidence for that. And I think the evidence is quite overwhelming that the majority of plastics, at least close to urban source areas, does come from land-based sources. One of the strongest pieces of evidence for this is the distribution of large litter items around the coast of South Africa. So we have this nice uniform coast with rather evenly spaced metropolitan areas. And we see this kind of distribution. Now, if most of the litter was coming from offshore sources, we wouldn't see this concentration of litter close to the urban centers. And we see this despite the fact that most of our beach cleaning effort is happening around those urban centers. So these are standing stock estimates, they're not arrival rate estimates. So this unequal distribution around the coast suggests that most litter comes from local sources. And it also suggests, as I said earlier, that dispersal at sea is surprisingly limited, perhaps. You might think that most litter, once it gets into the ocean, travels large distances, but this kind of data doesn't support that. And if you haven't seen this paper, this is quite a nice paper to go and have a read by Collins and Hermes, modeling what happens to litter coming out of the 5 urban centers in South Africa: Cape Town, Port Elizabeth, East London, Durban, and Richards Bay. Now, it's important to note that they seeded their oceanographic model with plastic items about 8 kilometers offshore. So it's not really indicative of what happens because you know, there's a lot of dynamics going on within those close inshore waters that are not being captured by this. But for those litter items that get out into the ocean far enough to be included in this kind of broad-scale oceanographic model, what it suggests is that more than 60% of it, even though it's managed to get 8 kilometers offshore, will wash ashore. And those sort of color shaded areas north of Cape Town and east of Port Elizabeth and so on, that's where they predict the litter should wash ashore. So the gray arrows give an idea of how much litter should wash ashore. The red arrows, how much is going to go into the Indian Ocean, and the blue arrows, how much is going into the Atlantic Ocean. It's worth noting, though, that they only released items from Cape Town into Table Bay. They didn't consider the litter going into False Bay from the Cape Flats. So what about what's happening in those coastal areas? Maybe Collins and Hermes are really, even though they suggest 60% of litter washes ashore, maybe it's even more than that if we actually go and look at what's happening within coastal waters. And this is where the lockdown came in. While we were all sitting at home last year in April, going a bit mad, we were fortunate enough to get a permit to go onto the beaches. And I'm fortunate enough to live on the shores of False Bay. So it was very easy just to stroll down and do some sampling along the coast of False Bay. And this is where we have a coastal wetland coming in. So we were able to look at litter coming out of that wetland and see where it went. So this is a zoomed in Google Earth image. So we've got this nice long sandy beach. We sampled 2.4 kilometers of sandy beach on either side of the mouth of the Sandflay estuary. And this is what Sandflay looks like. A lot of the time, it unfortunately receives rivers coming across the Cape Flats. And despite the best efforts of various people to intercept that litter before it gets into the flay, it still carries a large amount of rubbish like this. And obviously, once the river mouth breaches, a lot of that litter goes out into the sea. And the reason why we were able to take advantage of the lockdown was most of the time, this is what the beach looks like at Muizenberg. And it's very difficult to control what's happening on a beach when you've got hundreds of people walking along it the whole time. So the beach is cleaned by the municipality every single day, but also people walking along just out of a sense of good neighborliness pick up a lot of the rubbish as well. So it's really hard to get an accurate estimate of how much litter there is and where it's coming from. There's obviously also littering by people on the beach. But when the beaches were closed due to COVID, we had a very fanatical police force who used to come and check our permits about 5 times a day. And the beaches really were quite deserted. It was amazing to see how the birds in particular responded to these changes, but that's another story. So we collected selected litter items along this 2.5 kilometers of beach for 2 months. And we related that to the local rainfall pattern. And the estuary for the first month or so was pretty much closed, well, entirely closed. And then just ahead of the first winter storm, the municipality came down and opened the estuary mouth so that there wouldn't be flooding inland. And that's just a graph showing the rainfall events. So relatively little rainfall up until the end of May. And then we had a succession of cold fronts bringing rain into the area. And this is what we saw in terms of litter arrival rates. So as expected, once the river mouth was opened, we saw this massive release of plastic out of Sandflay onto the beaches, and then some spikes thereafter associated with rainfall events, but nothing quite as big as that first flush of litter out into the ocean. And what was most interesting to me was how spatially constrained that flush of litter was. So this just shows in relation to the estuary mouth what the density of litter was. And I haven't put in a slide showing you the density before the river mouth opened, but basically it was pretty much flat with a slight peak at the west end of the beach. But there was no evidence of an increase around the estuary mouth. As soon as the estuary mouth opened and we got this first flush of litter, we saw this massive spike in litter within about 200 meters of the estuary mouth. So it really was very, very confined, which to me was quite surprising. I was expecting the distribution to be more smeared along the coast. So I guess the message from this part of the talk is that beach cleaning does more than just raise awareness. It makes a significant reduction in the mass of plastic that's getting out into the ocean, because by cleaning beaches, we're actually catching a large proportion of the plastic that's coming from land-based sources, because contrary to perhaps what you might think simplistically, it seems that a very high proportion, at least in the case of False Bay, is washing up relatively close to river mouths. And we did some nice trials with marked litter items to see what proportion was washing ashore. And in the case of sandflay, it was more than 90% of the floating litter items were washing ashore. And then another sort of encouraging thing about cleanups is data suggesting that the things that we pick up during beach cleanups make up more than 90% of the mass of plastic on beaches. And this is surprisingly a topic that hasn't really been explored, despite all the work that's been done on sandy beaches around the world. We couldn't find a study that had really tried to quantify the abundance of plastic by size spectrum across the whole range of sizes on the beach. So what we did was we went to a remote beach in the West Coast National Park where there was no cleaning effort, so it was a pretty dirty looking beach and hadn't been cleaned for many years. And we then sampled for microplastics, mesoplastics, and macroplastics. We dug down 15 centimeters and sieved the sand for macroplastics. And we dug cores going 15 centimeters for microplastics and so on. And if we look at the number of items, not surprisingly, we find that there's enormous numbers of microfibers. Interestingly, microfibers are not concentrated at the high tide line as all other plastic items on sandy beaches are. So virtually all the plastic items you find washing up on sandy beaches float, and so they get pushed with the tide to the high tide line, and you find a succession of strand lines from the most recent high tide line through the spring high through to the storm high. But microfibers become embedded in the beach structure, and we find them from right up at the top shore, right down to the spring low tide, and we find them buried down with more or less equal density throughout the beach profile. So a very different behavior of microfibers, once again suggesting that microfibers should be treated as a separate category of synthetic products rather than plastics, because again, many of them are not actually plastic anyway, a lot of them are natural fibers. But be that as it may, numerically, microfibers are enormously abundant. Other microplastics and mesoplastics make up obviously a large number of things as well. And macro litter makes up a tiny proportion of what we find on beaches. But once we look at mass, we find a very different picture. So more than 90% of the mass of plastic on an unclean beach is sitting on the surface in big items that we would pick up if we did a half decent job of cleaning the beach. Most of the rest of the mass of plastic is sitting in big items that are buried within the beach structure. And a tiny proportion is sitting in microplastics, and microfibers account for virtually nothing in terms of mass. So even though there are literally hundreds of thousands of microfibers per meter of beach, their mass equivalency is around about 1 to 2 nurdles per meter. So they really are trivial in terms of their contribution to the mass of plastic in the environment. And another good thing about cleaning macroplastics is if we take them off beaches, it stops them turning into this sort of plastic confetti, which is much more difficult to deal with. So beaches are particularly good places for breaking down plastics. They've got typically high UV levels, and there's often a lot of mechanical abrasion associated with wave action and wind-blown sand. And so we see plastic becoming brittle and breaking up into smaller pieces. And once it gets down to the size beyond which it's easy to pick up, it's much more difficult to deal with. Of course, I'm not advocating beach cleaning as a solution, certainly not in any sort of long term. We should be tackling the problem much closer to the source. So moving inland, we should be intercepting upstream. So this is a picture from California showing a temporary river system on the border with Mexico. Just huge amounts of plastic being retained by a net system on this river system. These kinds of mechanisms, obviously, again, are just stopgap measures, finger in the dike stuff, while we come up with more lasting solutions. Ultimately, the solution to the plastic problem is going to be a change in human behavior more broadly, changing the way that we interact with plastic. So in terms of future research priorities, I think if we go back to what I started by saying, we've known for 25 years that there's a problem. we shouldn't really be doing more research on quantifying the problem. The focus should be on mitigation. And I think from an ecological perspective, the primary research questions are around informing what approaches best tackle the sources of plastic getting into the environment. And this paper we wrote last year looking at sort of monitoring how will we know if we're making a difference. That to me is the most interesting question. You know, it's up to social scientists and policymakers to implement mitigation measures, and we can tell them whether those mitigation measures are being effective or not. So we want to know if the amounts and sources and the composition of plastics in the environment are changing. To do this, we need to focus on fluxes, not standing stocks. So generally speaking, if you just go out and sample snapshot views of what's going on, it's very difficult to interpret what that means in terms of the kinds of questions around, are we making a difference? Because it's very hard to disentangle accumulation and turnover in a lot of compartments in the environment. And in terms of monitoring, what sizes of plastic should we monitor? There's a huge amount of focus in the last decade or so has been around microplastics. And this makes sense from an impact perspective because microplastics are mostly a problem in terms of ingestion, which arguably is the largest environmental concern around plastics. But if we look across the size spectrum from nano right up to mega, I think that the message from the Sandy Beach data and from the at-sea data in the North Pacific Gyre, although as you move down the size spectrum, things become more abundant. In fact, the mass is all sitting up in a few large items, which is encouraging from a mitigation perspective. If we can deal with those few large items, we're tackling most of the problem. Obviously, in terms of environmental risk, ingestion is more of an issue for small plastic items. Entanglement is one associated typically with larger plastic items. Definitely in terms of ease of sampling, it's much easier to work with large than small items. If you want to know where it comes from, you definitely get a lot more information if you work up towards the macro end of the scale, as hopefully our bottle data shows. And in terms of mitigation, I think, again, coming back to solutions, we can do a lot more at the large end of the spectrum than we can at the small end of the spectrum. My pragmatic approach is to say, you know, microplastics are out there. There's not much we can do about those that are already out in the environment. Obviously, we should stop releasing any more primary microplastics. But in terms of ongoing mitigation, our focus should be at the macro scale, because if we don't deal with the macro, they're going to break down into micros in due course. So that's my kind of somewhat individualistic, perhaps, long-term view of plastics, having spent 35 years dabbling in plastics research. I hope it's been interesting. It might be a little bit different to some of the other stories that you're used to hearing about plastics. But yeah, that's my story. I hope it's been interesting.
Thank you, Peter. There are a few questions that have come through already. From the first one from Salim says, does the fact that Asia increased percentage-wise mean South America decrease, or has Asian litter just exploded in number?
I suspect largely the latter. So I think what has happened over this time is the shipping route between South America and Asia has grown in the last sort of 2 decades, associated with the growth of the Asian tiger economies. So lots of raw materials are being moved between South America and Asia, and I think that's the primary driver. But it does seem that it's shipping companies servicing Asia that are the primary culprits when it comes to illegal dumping of general waste at sea.
Then there's another comment that says metal foil chip packets seem to be the main culprit of litter, must definitely be the target 1 eliminator list for plastics packed target groups. I don't know if you want to comment on that, Peter?
Sure. So I'm not really in the chip packaging market, so I'm not sure what the alternatives are. I guess that they have to put the foil in to stop the chips going stale quickly. So it's all about shelf life. if it's any consolation, I mean, yes, I hate chip packets. Anybody who works in an urban environment in South Africa will know that they are a huge component of the litter stream. The only silver lining to that I can suggest is that they don't travel far. So you'll never find a chip packet far from a human source. They're very close to neutrally buoyant. And once they get into the sea, they tend to sediment out pretty quickly. So I didn't really talk about dispersal at sea too much, but flexible packaging is not good at long distance dispersal. So just because it sediments out quickly. Even things like polyethylene bags, which are more buoyant than chip packets, also don't disperse terribly well. We picked one up in a trawl survey 200 meters down. It was less than 3 months old. So it had been in the ocean definitely, at most 2.5 months. And yet it had already managed to disperse offshore, or maybe it was dumped from a ship, but get to the point where it was sedimenting out due to biofouling. So it was down on the seabed.
Thanks, Peter. There's a question from Sizokazi that says, "Hi, Peter. Thank you for the informative presentation. Can you suggest places where we can drop off plastic bottles, caps, eco bricks, etc., and other recyclables around Cape Town? We're based in the southern suburbs."
Eco bricks, I don't know. So the city of Cape Town has various recycling points. There was a really nice one just off the M3, but that's closed because they built that swanky new Checkers. So I tend to drop mine at Constantia Village depot, but if you look on the municipal website, there are municipal drop-off centers. A lot of schools also collect particularly high-value things like HDPE lids and polystyrene bread tags and so on, because they have real cash value. So yeah, but I can't give you a massively specific answer on that.
Thanks, Peter. There's another question that says, what impact has the COVID lockdown had on the accumulation or production of mismanaged waste?
Yeah, we did a little project during the first stages of the lockdown, sort of from level 5 through 4 through 3, looking at street litter, and as my wife said, it's not rocket science. She was astounded that we managed to publish it, but basically there was a linear increase in the amount of litter as the lockdown eased. So under level 5 lockdown, there was very little litter, and as people were given more and more freedom to move around, so the amount of litter on the streets increased. Interestingly, there didn't seem to be much of an impact of the lockdown on beach litter, but I think that was largely because most of the litter that we were picking up on the beaches had been already entrained into storm drains, and it was just waiting for the first winter rains to wash down into the sea. As COVID has continued, I think probably overall it's been negative, like it has been for most conservation-related things. So just by reduced quality of services, people are resorting to dumping illegally, perhaps more so, and definitely there's been an increase in the amount of sort of plastic-related PPE stuff. So, we didn't see many masks in the early stages of the lockdown, but if you go down to a beach now, it won't take you long to find somebody's disposable mask lying around or some disposable gloves. And there's just a lot more packaging being used because of concerns around corona. People are not, less prepared to reuse things because of concerns around the virus and so on. So overall, COVID has been pretty bad news for the solid waste problem.
Thank you, Peter. There's a question from Refilware that says, is chemical contamination a concern with large plastics as much as with microplastics, particularly because of ingestion is not an issue with microplastics?
No, so there's two issues with chemical contamination. One is to do with chemicals that are incorporated into the plastics during manufacture, and anything to do with sort of food packaging. Obviously, the plastics are pretty clean in that regard, and so those are not an issue in terms of ingesting. But the other problem with plastics is they absorb persistent organic pollutants from the environment, because a lot of these persistent organic pollutants are sort of hydrophobic. They don't like water, and so they see plastic as a safe refuge when they're drifting around in the ocean. And so if you leave bits of plastic drifting around at sea for a while, they slowly soak up things like DDT and PCBs and so on. And their ability to soak up plastic is very much related to their surface area. So small plastic items will be much more efficient at soaking up environmental plastics than large plastic items. So certainly, again, microplastics are the problem there. You've got lots of them with a huge surface area. So they're going to be much more effective at soaking up those plastics. Again, you know, bottom line, don't let things get small. Let's deal with them while they're still big.
Thanks, Peter. There's a question from Holly Nell that says, is the bottle identification technique difficult? Sorry, and it goes on. How possible is it to develop an identification key or training to roll out programs across Africa?
It's not difficult, but it's more of an art than a science. So it's something that we kind of learned. So I now consider myself something of a natural historian of bottles. You know, so myself, Mael Conan, and a couple of our students, you know, we can spot a Nong Fu spring bottle from 50 meters, you know, because we've just looked at literally thousands and thousands of bottles. In theory, we could, you know, you could develop a field guide for bottles, just as we could have a field guide for spiders. I don't think they're probably as hard to identify as spiders, but they're probably not any easier than something like birds or butterflies. You know, there's a lot of subtleties, so you kind of need to put in the experience. You know, it's not entirely. I mean, yeah, it's somewhere. It's not something that you can just go out and do without having. You know, we become better and better. The more places we visit, the more we suddenly realize, damn, that's what that thing is. You know, yeah, it's 2 years and I don't know, 30,000 bottles of experience has got us to a point where I can identify 90% of bottles, but you know, there's always some that I kind of go, well, I know this isn't local, but I don't know where it comes from. And there's certain brands that we still haven't found. There's one called jewelry. We find these jewelry bottles, and we do a lot of Googling to obviously identify where they come from, but we haven't been able to identify a jewelry yet. So we're still hoping to find one with a label which will tell us where jewelry comes from. There's a Japanese brand jewelry, but it's not that one. So yeah, it's fun. It's like a detective game, but it takes time to get to the level of expertise where you can identify a high proportion.
Thank you, Peter. There's a question that says, PET bottles make up the bulk of macro litter on South African beaches. What negotiations are being undertaken with manufacturers to put a deposit on these and put value back in them so that they can provide an income to litter pickers and be recycled in a greater proportion?
Yeah, I disagree with saying that PET bottles make up most of the litter. It depends, again, what your currency. Are you talking numbers or mass? Certainly not in terms of numbers. In terms of mass, they, you know, depends where you are, but I would say overall, if I was to integrate across the African coastline, definitely I wouldn't put PET bottles as the top thing. Having said that, I think the big multinationals are getting quite nervous about the sort of consumer backlash against single-use plastic bottles. So Coke has been trialing this returnable 2-liter bottle with an R8.50 deposit in the Eastern Cape and in Mpumalanga, I think. And that seems to have been going quite well. So hopefully we'll see that roll out. You know, the concern is always the smaller manufacturers are going to always be late to the party. So I think, you know, Coke will probably start to act sooner than anybody else because they are acknowledged as the #1 polluter of bottles in the world. And then it'll maybe filter down from there, but yeah.
Thanks, Peter. I see she did post a comment that said, sorry, the Durban area. So I think that's the beaches she was referring to. Then there's another question that says, thank you for this informative talk. Do you think that recycling and using bioplastic is the alternative solution to the plastic pollution crisis?
You know, we wouldn't have been wrestling with this problem for 25 years if there was a single easy solution. So, you know, it's not like recycling is going to solve the problem. I don't think, you know, degradable plastics is going to solve the problem. We need a much more nuanced and diverse response, set of responses to really make a difference. So we need bottom-up action, we need top-down legislation to level the playing fields. You know, so I think we're moving in the right direction. Things like the legal enforcement of extended producer responsibility is pushing from the top down in the right direction. You know, the groundswell of popular consumer resistance to overpackaged plastic products is pushing in the right direction. But there's no single solution. I just caution against a kind of knee-jerk ban plastics, because, you know, you need to look at the full set of environmental costs of the alternatives as well. And in many cases, plastics are the best solution for the problem. Even in single-use packaging, plastics can be by far the best solution. The problem lies in how we deal with them once we've used them for that single use.
Thank you, Peter. While the topic of bioplastics has been brought up, have you discovered any bioplastics through your sampling? Because I know a lot of them are designed to biodegrade in industrial composters and things like that, and they aren't necessarily marketed as such. So I was just wondering if you've come across any in your sampling.
Yeah, they're extremely rare. I think we've had don't think we've got any bioplastics, so-called, in Kenya. Don't think we've had any on the islands. I know we had one in Cape Town and maybe one in PE, but they're very small segment of the market. You know, you tend to be paying a premium for them. I think the people who are paying that premium potentially might be less prone to littering, although that's perhaps controversial. But you know, I don't think that the absence of them reflects that they're degrading or anything. I think it just means that they're a very small market segment. I mean, what really, I get so incensed with these bloody bioplastic dog poo bags. You know, people think that they're going to magically disappear. You know, within a day of the beach opening at Muizenberg, we found somebody, you know, carefully picked up their dog poo, put it in a green bag, and then left it on the beach. You got to go like, what? Where do they think it's going to go? You know, you may as well just leave your dog poo on the beach if you think the bag's going to disappear. I've had one of those you know, Bonnie Bio poo bags in my composter in the garden for over a year now, and it still looks fine. So this so-called compostable PLA is definitely not, you know, it's industrial composting. It's not domestic composting.
Thank you, Peter. Then there's another question that says, hi there, thank you for the informative talk. Have you monitored microplastics from marine sewage plant outfalls?
In a word, no. So microplastics, I mean, it depends what you're talking. Most of them tend to be fibers, which are a nightmare to work with. So I've dabbled with fibers and decided that they're not for me. So I'd rather work with bigger things. So yeah, no.
Thanks, Peter. And then there's a comment from Salim that's referring to the PET bottles and the EPR, saying PET bottles are among the best for recycling and thus surprised to see it among the litter. Swap shops are a great as an attraction, and EPR will also address this. Definitely lots more needed on education and awareness and market creation, but just a comment.
Sure. So, I mean, if I can comment on that, look, Petco is often held up as a great model of industry-led recycling. And they've done a pretty good job. You know, they're up to close to 70% of PET bottles get recycled in South Africa, according to their statistics. But you just have to turn that on its head and say, okay, so 30% are not being recycled. How many PET bottles do we make? Close to 5 billion. You know, that means 1.5 billion bottles are going into the environment. Okay, a lot of them might be in landfill, but it's still a shed load of plastic bottles going into the environment. So yeah, you know, it's great having a value associated with these things and having recycling schemes with some rewards, but I think those rewards need to be bigger. Certainly, you know, in my neck of the woods, it's very easy to pick up PET bottles along the street, so they're not valuable enough even for people with very limited means to be bothered to pick them up. So the model isn't sufficient to capture a high enough proportion yet.
Thank you, Peter. There's one last question that says, what do you think the various initiatives like litter booms that prevent waste coming down the river from sources, and are there any great initiatives in South Africa that stand out for you?
Ironically, there's a guy at University of Cape Town, Neil Armitage, in the civil engineering department, who in the 1990s designed a whole bunch of really cool ways of intercepting litter in rivers. And they've been adopted in places like Australia, New Zealand, Canada, but never been adopted in South Africa. So we have the know-how how to do this. The litter booms are pretty, sort of marginal. Depends on the design, of course. I don't know. We've just got a contract from the CSIR looking at trying to get an overview of what interventions are in place around the country, and how the designs differ, and then we'll be doing some trials to look at their efficacy. But I think the simple litter boom definitely makes a difference. We've seen in Table Bay in Cape Town, the daily arrival rate of litter in summer has decreased, and the obvious reason for that is because of all the litter booms that have been put up on the Black River. But I don't think they're massively effective because they're just trapping the surface. And under high flow situations in winter, we don't see any effective litter booms. So we need something that's more effective when there's a high flow situation.
Thank you so much, Peter. I think that was very informative. There's one last question that says, do you find that there's a difference in environmental awareness between Durban and Cape Town?
I don't really spend enough time in Durban to be able to say. I mean, I'm pretty shocked at the level of environmental awareness in Cape Town. Yeah, maybe I better not say much more than that.
Thanks, Peter. Those seem to be all the questions that we've got through now. But if anyone has questions at a further stage, you're welcome to email us at webinars@sstafrica.org.za. But just to close off, I just want to say again, thank you so much, Peter, for taking the time to talk to us today. I think it was incredibly informative, and it's not an area of study that I think people are often exposed to, but it's, yeah, you've been getting wonderful data. So it's great to see the trends that have come out from that.
Cool. Well, thanks for the opportunity to chat to you guys, and best of luck with all of your future endeavors.
Thanks, Peter, and thanks everyone for joining. Enjoy the rest of your day.